Hi guys, I'm going to run through one version of each quiz here. So I've got 5 questions from chapter 8, 5 questions from chapter 9. I know it might not be the ones that you worked out personally, but they're going to be very similar. So as a little bit of a review here, I'm going to work through some of these problems. So the first problem on the first quiz for chapter 8 was to simplify the sum. Before we do that, we always want to work a little bit smarter, not harder. So let's try and simplify anything we can first. Here, I can multiply to 8, add to 6 with 4 and 2. So x plus 4 times x plus 2 are my factors for x squared plus 6x plus 8. Again, multiply to 8, add to 6, both positive. Now I'm going to multiply to 12, subtract to 1. 4 and 3. And because I subtracted, I found the difference. My signs are going to be different. Sign in the middle goes to the bigger number. Now, in an individual fraction here, we can reduce if we want to. We can get rid of multiplication by dividing. X plus 4 divided by x plus 4, anything divided by itself is 1. So as long as we're multiplying, we can get rid of that by dividing, which leaves me with just x plus 2 over x minus 3 plus 7 over x minus 2. Now, towards the beginning of the year, I gave you guys a fraction cheat sheet, and this works the same way as it did before. We can't add fractions unless they have a common denominator. So we look at our denominators. Here I have an x minus 3. Here I have an x minus 2. Remember, those are one thing, one expression. So x minus 2 goes together, x minus 3 goes together. They mean one thing. When we plug a number in for x, we get one value. And I don't have any common there, which means my common denominator is going to be an x minus 3 from that column times x minus 2 from that column. Now, when I compare these, my first fraction here has the x minus 3. It's missing the x minus 2. So I multiply by x minus 2. And if I change my denominator, I've got to change my numerator as well. My second fraction has the x minus 2, but it's missing the x minus 3. So I have to multiply it by x minus 3. And if I change the denominator, I've got to change the numerator as well, in order to keep that part of my fraction equivalent. So now, both of my denominators are just my least common denominator, x minus 3, x minus 2. I'm going to multiply my numerators. FOIL here, x squared plus 2x minus 2x minus 4. And again, I have a common denominator here. 7x minus 21. Once I have that common denominator, I can go ahead and add across the top, add my numerators. So I get x squared minus 4 plus 7x minus 21. We're going to combine any like terms, which gives me x squared plus 7x minus 25 over that common denominator, x minus 3, x minus 2. We always want to try and factor here if we can to simplify. Multiply to 25, subtract to 7, there is nothing. So this, or I would take if you multiplied out your denominator. FOIL here, x squared minus 2x minus 3x gives me negative 5x plus 6. So either one of those is our simplified sum of here. So again, first thing we want to do is always simplify any fractions that we have. This first fraction we simplified by taking out that common factor. Greatest common factor, we divided out. Now we have to get common denominators here. And in order to do that, whatever we multiply the bottom by, we have to also multiply the top by. Again, whatever we multiply the bottom by, we also have to multiply the top by. Go ahead and multiply. Once we have those common denominators, we can write the entire thing over our common denominator and perform our operations on our numerator and add there. Same idea with subtraction, we would just subtract. So let's go ahead and try a subtraction one here. We're going to simplify the difference. So again, first thing we're going to do is simplify each fraction if we can. My first fraction here, I can go ahead and factor my numerator and factor my denominator. Multiply to 20, add to 9 are going to give me 4 and 5. Since we added or found the sum, our signs are going to be the same. Here, they're both going to be negative. Same idea in my denominator. We're going to multiply to 35, add to 12. So 7 and 5. Same sign since we found the sum, both negative. Now, because those are within one fraction, I have multiplication here. I can get rid of it by dividing. And remember, fractions are just division. So x minus 5 divided by x minus 5 is just 1, and 1 times anything is itself. We can get rid of multiplication by dividing. We cannot get rid of subtraction by dividing. So these x's right here, we can't do anything about because those are being subtracted. We cannot get rid of subtraction with division, only multiplication with division. So here, I have x minus 4 over x minus 7 minus 4 over x minus 6. Anytime we add or subtract with fractions, we have to have a common denominator. So when I compare my denominators here, I have x minus 7 in one fraction and x minus 6 in the other. So my common denominator, I take each column and I get x minus 7 times x minus 6. That's my common denominator. Okay, each factor is represented. So in my first fraction here, I have the x minus 7. I need the x minus 6. So I multiply by x minus 6 to make my denominator look like that common denominator I need. And if I change my denominator, I've got to change my numerator in order to keep that fraction equivalent. Same idea for my second fraction. I have the x minus 6. I need the x minus 7. So I'm going to multiply by the x minus 7, top and bottom. I'm not going to cancel them out here. I know that I have, just like I did here, where they were the same, but I need those in order to get that common denominator. This is my goal. So I'm not going to cancel those out because I put them there specifically for a reason. So now I have a common denominator. There. In my numerator, I'm going to go ahead and we will multiply these out. So FOIL, x squared minus 4x minus 6x gives me negative 10x plus 24. Here, I'm going to take the negative with my 4. I'm going to distribute that subtraction in. Otherwise, a lot of times we forget. So here I'm going to have minus 4x plus 28. And again, once we have that common denominator, we can write it as one fraction and perform our operations on our numerator. So I can take all of this together because I have that same denominator. So I write the entire fraction over my denominator, my LCD, and perform that operation. So I take the negative with the 4. Combine like terms, x squared minus 14x plus 52 over that common denominator, which we said was x minus 7, x minus 6. Or you can multiply that out. X squared minus 13x plus 42. Either one of these I would have taken. We do want to try and factor, multiply to 52, but add to 14. There is nothing that works there, so we cannot factor that numerator to try and simplify it any further. Number 3, we're finding the product in simplest form and stating any restrictions on the variable. Product means multiply, and when we multiply fractions, we multiply straight across. But just like we did before, I'm going to break these down into factors to see if we can simplify it, because we want it in simplest form. So x squared is just x times x. X minus 5 is already in simplest form. We only have one x there. X squared, we have a quadratic trinomial here, which means we can try and factor it. Multiply to 20, subtract to 1, which are going to be 5 and 4. Since we subtracted or found the difference, our signs are going to be different. Bigger number gets a sign in the middle, so minus 5 plus 4. And here, we factor out what's common, greatest common factor there. Means I can take out an x. What I'm left with is x plus 1. We always have 1 as a factor. Or we can divide them out. X squared divided by x is x. X divided by x is 1. Anything divided by itself is 1. Now again, with fractions, we multiply straight across. So it's like we make it one big fraction. And because now all my factors are being multiplied, we can get rid of them with this division in our fraction. Anything divided by itself is just 1. Anything divided by itself is just 1. So, in my numerator I have x times x plus 4. In my denominator I just have x plus 1. Or you can multiply your numerator and get x squared plus 4x over x plus 1. Now, any restrictions on the variable? Restrictions happen anytime our denominator equals 0 because we cannot divide by 0. Can't divide by 0. So we look at every one of our denominators. It's easiest to do when they're in factored form. And we make each of those factors equal to 0. X minus 5 equals 0 means x would equal 5 when we add 5 here. Can't have that. Cannot equal 0 because we can't divide by 0. So x cannot equal 5. Second factor here is x. So x cannot equal 0. Third factor, x plus 1 equals 0. We want to know what value of x would give us division by 0, and then we exclude that. So here x cannot be 5, 0, or negative 1, because if we plug those values in, 5 minus 5 would give us division by 0. Can't have that. If we plugged a 0 in here, we get division by 0. If I plugged a negative 1 in there, I'd get division by 0. We cannot have division by 0, so those are our restrictions on the variable. It does not matter what our numerator is, it just matters about our denominator. A complex fraction, guys, is just a fraction in a fraction, okay? It's like the top part of our fraction and the bottom part of our fraction. And if you think about it that way, guys, a fraction is just a big division symbol. So all we're doing here is dividing fractions. First thing I'm going to do is to simplify each of my fractions, get them into factored form. So the only thing I can factor here is my denominator of my numerator. Multiply to 4, subtract to 3, 4, and 1. Since we found the difference, our signs are going to be different. Bigger number gets a sign in the middle, so plus 4 minus 1. Now, because we're dividing fractions, we're going to flip and multiply. And it's always our denominator that we flip and multiply. We multiply by the reciprocal. So keep your numerator, flip your denominator, and multiply straight across. So denominator goes to numerator, numerator goes to denominator. We multiply straight across here, which means I can write these as one big fraction. Because we're multiplying, we can get rid of any common factors by dividing. The inverse operation for multiplication is division. So those x plus 4's cancel out. What I'm left with is x minus 2 over x minus 1 times x minus 7. Or, if you multiply that out, x squared minus 8x plus 7. Our restrictions come from any denominator we ever had. So from here, from here, from here, from here, or from here. So, in factored form here, we had x plus 4 cannot equal 0. So x cannot equal negative 4. X minus 7 can equal 0, so x cannot equal 7. And x minus 1, so x cannot equal 1.